Scientists love graphs, and when used properly they can help us picture what's going on much better than just a list of numbers. A great example is a distance time graph. A distance time graph can show us what's happening during a journey. On the x-axis you put time, and on the y-axis you put distance. Sometimes you may see displacement there instead of distance. I won't go into the difference in this video. Why not subscribe right now? Then you'll easily find my other videos, including one on the difference between vectors and scalars. In that video, I do discuss the difference between distance and displacement, as well as speed and velocity. Let's look at a simple journey. We're going to walk to the shops, and on the way to the shops, we stop and we tie our shoelace. When we start, our distance travelled is 0 and the time is 0. We then walk a total distance of 100 metres in 50 seconds. Admittedly, that's a brisk walk with our shoelace undone. We now take 50 seconds to tie up our shoelace. During that time, we are stationary. We are not travelling any distance. We then set off to the shops again, and we travel a total of 200 metres in 100 seconds. Once we're at the shops though, we don't travel any further. If we want to calculate speed, we do speed equals distance travelled over time taken. So for the first 50 seconds of our journey, the distance travelled is 100 metres and the time taken is 50 seconds. 100 divided by 50 gives us 2 metres per second. Another way to look at this is actually the gradient of the graph. Gradient equals change in y over change in x. The change in y in this graph is the distance travelled. X is just the time, so the change in x is the time taken. So the gradient of our graph is the distance travelled over time taken, which is speed. For a distance time graph, the gradient equals the speed. Let's take a look at our journey from when we set off after tying our shoelaces to when we arrive at our shops. We travel a total distance of 200 metres and it takes us 100 seconds. What is our speed? Well, speed is distance over time, which is 200 divided by 100, which is 2 metres per second. This speed is exactly the same as the speed before, and if we look at the gradient of the graph, we can see it has the same slope in this part of the graph as it does in the earlier part of the graph. That's because the speed is the same. Let's look at a couple of other graphs. In which graph is the object travelling fastest? Is it A or is it B? Hopefully you can see that in graph A there's a steeper gradient. That means the object must be travelling faster than it is in B, which has a shallower gradient. Take a look at this graph. During which section of the graph is the object travelling fastest? Is it A, B or C? And during which section is it travelling the slowest? C has the steepest gradient, so this is where the object is travelling the fastest. B has the shallowest gradient, so this is where the object is travelling the slowest. Remember, if you see the horizontal gradient on a distance time graph, then the object is not travelling, it is stationary. If you see a graph like this, you can see the gradient starts off shallow and then the gradient gets steeper and steeper. So the speed is increasing. We say that the object is accelerating. Before I show you the last graph, can I point you in the direction of my website? On there you'll find lots of free resources, including questions and answers to videos, including this one. There's also one-to-one lessons available, and I do my best to keep those as affordable as possible. So if you're interested, please get in touch. Again, information is on the website. Do also like and comment on this video. That way I can keep making these free resources. Finally, what's happening in this graph? Well, we can see the gradient starts off steep, so the object's moving fast, and the gradient decreases, so the object is slowing down. We often say it's decelerating. Now, why don't you watch this? Somewhere, just there. That'll do. That one. Go on, be a devil, watch it.